of you have a Windows laptop, so look at it and download the Windows one and install it. Once you have installed this, then you need to install RStudio, the free softwares. So, but this will not work until and unless this is properly installed on your systems. So you need to install this first and then this. And if any one of you have the doubts in installation, or if somebody is not able to install, you can WhatsApp me in the group. So WhatsApp me in the group only, so that if anyone else also has the same problem, it gets
Ma'am,
solved for everyone. Okay. Yes.
ma'am, I did this R Studio in R, but after working for some time now, it's not loading my package.
It's not loading your package means.
The package R Studio and R Raster GIS, these ones.
You come to the department.
Okay.
Yeah. For rest of you, you all do this, and as I said, any problems discuss in the WhatsApp group. Okay.
Okay.
And regarding yesterday's practical, what did I give you some assignment on that or no? In the end, anyone? Anyone? तुम लोग जवाब नहीं
प्रैक्टिकल में तो नहीं था असाइनमेंट.
कल मैंने कुछ बोला नहीं था कि ये करके देना.
थ्योरी क्लास का था ना वो इक्वेशंस वाले.
कौन सा?
लाइन इंटरपोलेशन, क्वाड्रेटिक इक्वेशंस, स्लोप,
उसमें क्या बोला था मैंने?
मीन स्क्वायर एरर.
मीन स्क्वायर एरर वाला बताया था ना, तो फॉर्मूला बोला था. प्रैक्टिकल में मैंने कल कुछ नहीं दिया था.
Yes, ma'am.
हाँ,
दिया
दिया. क्या दिया था?
पेन शार्पन का वो तीनों का बताना था.
पेन शार्पनिंग वाला बताना था, राइट. एक और प्रैक्टिकल करना है. यू ऑल हैव टू डू वन मोर प्रैक्टिकल. The point is, I can tell you to do the practical, but I want you to learn understanding how to use the software on your own. Okay, so that anything you want to do, you can do in it. Are you understanding my point? सब
Yes.
कोई समझ रहा है? So you have to do one practical called IDW interpolation. Okay, download any CSV file of any kind of sample data like air data, or what do we say, temperature, rainfall, any kind of point data, and use IDW interpolation. Got this? Everyone got this?
Yes, ma'am.
Ev- ev- Everyone got this?
Ma'am, please repeat.
I said you have to also do one IDW interpolation by yourself in QGIS. That is, go on the Google, download any kind of air parameter data, rainfall data, temperature data for the any point location data. So when I'm saying download it, that means you should all not share it among your own selves कि सबने एक ही data download कर लिया और फिर बोलो कि नहीं हमने खुद से download किया था. Okay, so you download that data and do an IDW interpolation in that. Got this?
Yes, ma'am.
And I'll be checking in your next class then. Okay, it's a simple thing. It's not that difficult to do it. I'm just asking you to do it on your own so that using a software also becomes comfortable. And we already have studied IDW interpolation. Can you see my QGIS?
Yes, ma'am.
So if I type interpolation here, you can see it's directly coming here, right? So this is your IDW interpolation here. Okay. So you just have to do this, provide your vector. What is a vector layer? Anyone? वेक्टर लेयर क्या होती है? कौन जवाब देगा? कौन है क्लास में? देबशीष। देबशीष,
Yes, ma'am.
वेक्टर लेयर क्या होती है?
Madam, it is used to store data.
तो रास्टर में डेटा स्टोर नहीं होता?
Okay.
फिर
मैडम इसमें वो स्पेशल डाटा स्टोर होता है।
रास्टर में स्पेशल डाटा नहीं होता? हम्म।
Yes, ma'am.
फिर थोड़ा तो पढ़ा करो, इतना सारा कोर्स करा दिया मैंने। कितने लोगों को टॉपिक्स चाहिए कि कुछ रिपीट हो? How many are there? Write in the chat. Are there anyone who wants some topics to be repeated? सबको समझ में आ रहा है, नहीं आ रहा है, एटलीस्ट इतना तो बताओ मुझे। देवेंद्र, what is a vector data? देवेंद्र प्रताप, yes.
Yes, ma'am.
क्लास अटेंड किया अभी तक?
Yes, ma'am.
की है?
Yes, ma'am.
कितनी क्लास अटेंड की है?
मैम कल वाली नहीं की थी, उससे पहले।
अच्छा, तो वेक्टर डेटा वाली की है ना? क्या होता है वेक्टर डेटा?
मैम दिस टाइप ऑफ स्पेशल डेटा
सिर्फ एग्जाम से 2 दिन पहले
अदर
पढ़ाई करते हो क्या सब लोग हैं? या जीएसआई में बिल्कुल भी नहीं आता रिमोट सेंसिंग? हम्म। अभी सब लोग मुझे बताओ, कितने यहाँ पे हैं जो पढ़ाई कर रहे हैं और सिर्फ जीएसआई की तैयारी कर रहे हैं? हम्म। तो वेक्टर लेयर ही नहीं पता है तो वेक्टर लेयर ढूंढोगे कैसे? बताओ, कौन बताएगा? पल्लवी।
Yes, ma'am.
व्हाट इज अ वेक्टर लेयर, पल्लवी?
Ma'am, storing the data in vector format.
वेक्टर डेटा इज स्टोरिंग द डेटा इन द वेक्टर फॉर्मेट। ठीक है ये? सुजाता।
यस मैम।
क्या होता है भाई वेक्टर डेटा?
मैम जो पॉइंट्स पॉलीगन एंड लाइंस को यूज करके जो बनाता है।
पॉइंट्स, लाइंस और पॉलीगन्स को जो बनाता है, क्या बनाता है?
मैम डेटा फॉर्मेट, पॉइंट्स लाइन एंड पॉलीगन को यूज करके जो डेटा फॉर्मेट बनता है उसको बोलते हैं।
थोड़ा तो ठीक है, तो एटलीस्ट इतना बोला। अगर मैं बोल रही हूँ कि वेक्टर डेटा डाउनलोड करना, तो कहाँ से डाउनलोड करोगे? पल्लवी।
This I don't.
हाँ,
This I don't know.
यहाँ पे एक वेक्टर लेयर चाहिए, एक इंटरपोलेशन एट्रीब्यूट चाहिए। तो कैन यू ऑल डू दिस प्रैक्टिकल बाय योरसेल्फ? और
मैम शेप फाइल डाउनलोड करते हैं।
क्या?
शेप फाइल डाउनलोड करते हैं।
शेप फाइल डाउनलोड करते हैं। So all of you, you will have to download a shape file, a vector file or a shape file, which will have the data or the point data. That means rainfall at particular point. So it can be a rain gauge data with geographic locations. So a shapefile has a point data, line data, or polygon data with geographic locations. That is, if you plot it, you will know where is the latitude, longitude. You know the spatial attribute of that particular file. So you need to do that part. You need to find that certain data and use these three methods here. These two here, which I'm showing here, and one here. So these are just the three simple methods. At least point these or use these three methods and do this for your next practical class, that is on Tuesday. Okay, and the pan sharpening one. So you'll have 2 practicals to be done for the next, and if I'm giving it as an assignment, that means they will be marked also. Okay, anyone has a doubt in this? किसी को डाउट नहीं होता? चलो बढ़िया है. ओके, कल की क्लास का कोई डाउट है? कोई डाउट नहीं है? आगे पढ़ाऊं?
Yes, ma'am.
Chalo, let's talk about kriging. Okay, so what's kriging and what do we want to say here? So yesterday we talked about Thiessen polygon, IDW, and fixed local average. So what was happening in that any of those methods was they were deterministic methods. Deterministic methods means like it is giving you just the values, right? If you look at any of those methods, you were relating it with the distance or you were relating it with the average values, but what you were getting is you were just getting an estimate of the values, and somehow you were trying to cross validate it and see if which of the methods could be a better method. But there you are not able to get the probability, or you are not able to understand how much is the probability that a particular thing will happen. For example, you get the forecast of the rainfall, right? Everyone today have their apps in the phone which tell you the forecast of the rainfall, that tomorrow there will be no rain or tomorrow there will be this much of rain. So one, if we tell you that only, you don't know exactly how much that information is correct. So we told you a value that there is no rainfall tomorrow, but if I tell you that this rainfall comes with a probability of 50%, that means there are chances that 50% rainfall may occur or may not occur. So the truth in that value is 50%. But if I say that rainfall will not occur with the probability of 90%, that means there's only 10% chance that the rainfall might occur. Does it make sense? Everyone understands this point
Yes,
here?
ma'am.
So where the importance comes here is that we are simultaneously giving you the probability also, that okay, or we are putting in certain weight to that estimation, that if it is, we are saying zero rainfall with 90% accuracy, that means, or 90% probability, that means there are high chances that there will be no rainfall. As this probability goes down, our chances of the result being accurate also decreases. Okay, so when we are talking about kriging, that is what we are trying to do here, and we use the technique that it covers or considers both the distance and the degree of variation between known points. On this basis, it is able to give us the probability also. So it uses a minimum variance method to calculate weights. That means the weights are based on the variance. So this is a very general definition of kriging. So you have to keep in mind when we are talking about kriging, first of all, it is not a deterministic method, it is a stochastic method. So when we say it's not deterministic, is with the change in certain properties or methods, you can change the results which you are getting, unlikely in the deterministic methods. Okay, so that is one thing to consider here. The second is It's taking into consideration the degree of variation also between the known data points. That is the variance between the known datas. What is the variance of that data? So that is also taken into consideration here. So that is what I've already told or said, that we are not only quantifying the value, we are also telling the probability, that how much is it possible, or how much of the rainfall probability is there, whether it is a 25% chance or a 50% chance or a 90% chance. Okay, so basically it is giving you the confidence in the data generated. With IDW or the Thiessen polygon, whatever you get, you say, okay, this is the value, but you don't deliver the measure of confidence along with it. But here you are giving that measure of confidence, that how much your prediction is true. So if you say your prediction is 60% true, so that is the what, that much you have to rely on that data. But if you say it's 100% true, that means that's the most correct value you can get. So kriging helps you to identify or helps you in measuring the confidence of your prediction. Okay, also it helps, like when we are talking about IDW or the other methods, we take all the points as individual points. That means if 3 or 4 points are very nearby, then also they'll be treated as individual points. But here what we can do is, it can treat them as one single point because they are clustered together, or we might give less weight to the individual points within a cluster. So when you have done a sampling in one area, a lot of sampling in one area, then they will be treated as one single point rather than all points being treated as separately. And you give importance to the points or the datas which are also a little far away. Okay, everyone is with me? Everyone is able to understand?
Ma'am, please repeat once.
I'm saying when you have the IDW method, what were we doing? We were taking each known points individually, right? Each individually, and we were assigning based on the distance and the value of that parameter. That is what we did in IDW. Okay, so if you have a, I'll just show it again as raster here. So if we have a raster, okay, so if we have to take out the value of this raster here, okay, we have to calculate the value for this raster, and we have these points are known. So these points are known to us, okay, even if this is known. So now what is happening? What do we what is the logic in IDW would be, for this point we will treat all these 4 points separately, even though they are nearer to this point and all are in a cluster here, but we will treat them as separately, and these two again separate. So you'll have a value based on all these points individually along with these points. But when we are talking about kriging, what will it try to do is, it will try to give less weight in the individual values in this cluster. It will not provide it separate weights. But if you will take IDW, it will provide a lot of weight to all these 4 pixels here. But in kriging, all these together would have a high weight, but individually they will have less weight because they are in a cluster here. Does it understandable? Do you understand what I'm trying to say here?
Yes, ma'am.
Yes, ma'am.
Okay, so that is the point of kriging here, what we use. Okay, now there are mainly 4 or 5 types of kriging. So first is ordinary kriging. So what do we do in ordinary kriging is, we assume that the data, or how do we say, that there is no trend in a particular data. Okay, or if it is weak enough that we can ignore that kind of trend. in that we assume that the data have a constant mean value. Okay, but this mean value is unknown. So the model is based on this, and we call this method as ordinary kriging. I'm not giving you too much details here. I'm just giving you the general views of all the kriging methods. All these can be directly done in your algorithms, any of these algorithms in QGIS. I'm just giving you a little bit of knowledge so that if you are trying the different methods, you can understand what is happening in the methods. So if I say there's no trend in the available data points, what does that mean to you? Can anyone tell this? What does that mean? If I say there's no trend in the data.
Ma'am, scattered values.
Yes, scattered values, or there's, yeah, scattered values only. There's no trend. Okay. So if you look at this, we can treat it as like it's all going randoms. You don't have any relation what is here on the x-axis with the measured values. So wherever we put it, you will get a certain value and you don't know what is a trend here. And that is we employ in ordinary kriging. So when we are doing this, we just assume one thing here, that is it will now have a constant unknown mean value. That mean value has to be there and it is going to be constant. What do we mean by constant is that is it is not, we are not taking one set of data and providing a mean value. No, for all of the data we have one constant unknown mean value. Okay, that mean value will not change for the whole data range which we have here. Okay, and they are, the values will vary in between that only, between that range only what we have for the data here. Okay, so that is your simple ordinary kriging. Now if we talk about the universal kriging, that means for that we are assuming that data has a certain trend. Okay, so it, because there is a trend, it doesn't have a constant mean value, and for this we calculate the regression coefficients, and this model is called universal kriging. Do you know what is a regression coefficient?
No, ma'am.
No. Okay, so suppose, I think I have told this part before also when we talked about correlation. Okay, I think I've talked about correlation before also. So here also I'll talk something about that only. So we have two variables, one on x-axis and the other is on y-axis. So if I draw a line like this, these are the points. What can you see? What does it tell you? If you have these 3 points, what does that tell you? Does it give you some kind of information between these two variables which we have here? Anyone?
Positive linear relation.
Yes, it's a positive linear relation here. So that means if we have a point here, if we plot this point on x-axis, we have a point here. So where will it go? We will be able to estimate the value of y also, because it is going to intersect here and this will be your y value. Right, everyone? Is that true?
Yes.
Yes, ma'am.
So this is your positive linear relation, right? You made it a point or you got it like it, you what do we say, you over extrapolated this line and you got this point and you will know the value of y here, because this is a simple linear equation. So what is your equation here? Your equation for the linear one is y is equal to
Mx plus c.
y is equal to mx plus c. This is your simple equation. Now when we are talking about this kind of. So what we are doing, we are fitting a line here to the data which is available to us. So this can be in any form here in which it gets fitted. It could have been linear also, that would have been like this. It could be any other, it could be exponential, log form of data, or any other. So when we are saying regression, generally we start with a simple linear equation, which is your y is equal to mx plus c. If this doesn't work, we go to the next equations in which we increase the number of variables so that our equation can fit to the available data which we have here. So that is what we have done, and fitting the data is called as regression. So you can have linear regression equations which could be for with a single variable, or you can also have multilinear regression equations. Multi would mean you are correlating not only one data but maybe 2 or 3 data to predict a third variable here. Everyone gets this? Any questions here? See, if you're not getting it, you need to ask the question. Okay.
Ma'am,
Huh?
and there has to be only one equation to justify all the points, or there can be different segments of the data.
Oh, okay. This is a good question. It depends, like, what kind of a data are we using here. Okay, if we are looking at a seasonal pattern, something which is related to season, then what we would do is we would partition it into the seasons, and we will have different equations for particular seasons. But if it is a certain data which can fit in one equation, we can do that also. I'll give you one simple example here is, you have taken out NDVI, or the normal difference vegetation index. Did you plot it?
Yes, ma'am, last time we did.
Yeah. So what is NDVI telling us? It is telling us the health of the particular vegetation. Okay. So for any crop, you will notice crop has a cycle, right? When you put the seeds, then they grow into plants, and then you harvest them. So that is your crop cycle. So how does NDVI look at it? If when you have just plotted it, it's more of a soil. So your NDVI values would be very low. They will be down below. So if you have this here, they will be low. But as the plant grows, your NDVI values will grow high, and then it will again lower down with the harvesting of the crop. Okay, so you might have this kind of a data there. Now what we can do is, when we are creating these equations, we can divide them into 3 equation periods. That is one period where we have a linear trend going up, one where it doesn't matter at all and it's equivalent, and one where there's a linear downtrend. So this is a very simple one where you will say it is a bell shaped, and we can have one equation for this bell shape. But with the seasons, we might have a difference where we have to relate 2 variables or the 3 variables, where we can relate it with the temperatures also. So I just want to say that when you are telling, can we have one equation or multiple equation, it depends on the number of variables you want. If you want just one single variable, you might have only one equation. But if you are relating 2 or 3 variables, you might want to divide it into 3 different zones. Okay, so if you are using 2 to 3 variables, your equation becomes more complex, but the estimated variable might be more accurate. Okay, does it somehow answer your question?
Yes, ma'am. Good.
Okay, so this was about universal kriging. Now there are 2 more kriging. One is simple and one is indicator. So when we are talking about a simple kriging, then this is the model equation, and we are saying we have a constant mean for the entire data set. Okay, that's your simple kriging equation. When we are talking about the indicator kriging, what we do is, we take one threshold value. Okay, so we indicate that threshold value, and as it says in indicator, so we interpolate in a way, we just give 0 and 1 values, that whether it is above the threshold value or whether it will be below the threshold value. So it's just an indicator kriging. So if you look at this figure, it is for the same points which we have, how the results vary in each of these. Here you have a constant unknown mean. In this, you have a constant known mean. Here, it is based on the fitted equation or a regression equation. And here you have a threshold and you have all the points below or above this mean threshold value. So this is how these four will give the difference in the data. So whichever interpolation you are trying, you can look in all the 3 or the 4 methods here and see the difference here. Okay. Everyone gets it? Somewhat.
Ma'am,
Uh,
that means the difference between ordinary kriging and simple is that in simple the mean is known.
yes, we assume the known mean. Whatever the sample points are, we'll assume that this should be the mean here. And based on that, we calculate the errors with the other points. Okay.
Okay.
That mean value you can always change when you're running this code. You can always change, and like it's a random mean value which you suggest in the beginning, and you can always change and see how is your result coming up when you validate it. Okay, like we did the cross validation, you can do the cross validation in this also, and you can change that mean value, but you consider it as known here. Okay. Okay.
Okay.
Okay, now it gets a little bit
Ma'am?
more. Manji.
Ma'am, is it can be done with the ordinary one? Like change the values though it's unknown?
In ordinary, like it's not dependent on us, it's dependent on the iteration, number of iterations you tell the system to do. If you tell it to do only one iteration, it will choose one mean, and it will base your results on that mean. But if you tell it like, okay, you have to cross validate and you need to have like keep on iterating to have better results, then it will change the mean by itself. Okay.
Okay, ma'am.
Now, this is, we talk about the semi-variogram. So what does it helps to do is, it tries to quantify the autocorrelation within the variance of all pairs according to the distance. What is autocorrelation now? I usually give this example. Autocorrelation is, for example, now these days you have this open book examination. So everyone is autocorrelated, or there are groups in that. If you are a group of 5 friends, you will notice that all those 5 friends would have a similar language in the paper. So you are able to find out, okay, these 5 people copied it together and these 5 people copied it together. So you get to know that. But when you had your physical exam, what would happen? If one had written something wrong, so the nearby students would be also having that wrong if you're copying it, right? As you go far from that student, that correlation reduces. Am I right or no?
Yes, ma'am.
Yes, ma'am. मतलब copy करते हो. So that is your auto correlation. So we are saying they have small variance or small semi-variance when they are close together. When they are far, there's a high semi-variance. So these graphs which we try to create are called as semi-variograms. So this is the autocorrelation which I am saying. If you have 2 data sets, how is it correlated? So here you can see there's a high correlation. Here it is a totally what it is? It's scattered. So the correlation or autocorrelation is not there. Okay. So if we go by the definition, it is a plot of the structure that describes relation between the measurements which are taken at some distance. Okay, so we get this kind of a plot here. So what we have three things in this: cell, nugget effect, and the range. So what are we saying is this autocorrelation, it reduces or it doesn't have an effect after a some time. It levels off. That means it is leveling off here and there is no autocorrelation after that. So where it levels off, this point or this is called as your range. And where it intercepts at y, it is called as cell. And this is the nugget effect. Nugget effect is, it should actually start with a 0, but it's not intercepting at 0 and it's a little higher on this. So this is your nugget. If you have a linear data which is at 45, that nugget would be 0. So it should usually be 0, but in real situation, it starts from here and this is your nugget. So in a semi-variogram, we have 3 points here: the nugget, the cell, and the range. Okay, so range, if I repeat it again, when your autocorrelation or this levels it out, we have a range. So if you have a linear plot or a linear data, what would be it? It will be going, it will be like this. That would be your linear. So it might not level up. So what we do in that data is we approximate the cell and the range. Okay. But in other, like your log or exponential, you get these kind of leveling of the data. So wherever there is a leveling off, that creates your range. The y-intercept is cell, and the line or this, what do we say this? For the intercept of this, it is nugget. Everyone gets these 3 points here?
Yes, ma'am.
Okay, so let's talk about this simple example here. You have this data here. This is the unknown point, and you have these 5 known points. Can you calculate what would be the, if we do the IDW interpolation, what would be the value of this point? Can you do the IDW interpolation for this? Can you all do it? कर रहे हो कि नहीं कर रहे हो?
Doing it.
Okay. These points are shifted a little bit. So this is 1, this is 2, this is 3, this is 4, and this would be 5. Everybody is able to solve this? What are you doing in this? Everyone is getting it?
102.7.
102.77.
0.77.
This is with IDW.
Yes, ma'am. I'm taking the radius as 1. Right?
What radius?
Distance between the values, unknown points to the known points.
How did you take it as 1?
Like it's given like 0, 1, 2, 3, 4. So from the unknown point to unknown, I've taken as 1 unit.
Okay. Do you think it is correct? Ruchi?
Should be, ma'am. Because when you consider the distance, that's the only thing given.
So the distance what is given to you, you have to see it's in xy. How will you calculate the distance? So this point lies at 1,3 and this point lies at 1,5. Think what distance you have to use here.
मैम
मैम
आप एक बार करके बता देंगे कैसे करना है?
नहीं,
हम डिस्टेंस तो अननोन टू नोन ही लेते हैं ना. लाइक अननोन पे 1 4 है और नोन पे 1 5 है. देन अगेन डिस्टेंस 1 ही हुआ.
भाई distance between 2 points चलो okay, let's do it that way. बाकी सबने कर लिया ऐसे सॉल्व. किसी और ने सॉल्व किया कि नहीं किया अभी? कोई जवाब ही नहीं दे रहा. कोई क्लास में है कि नहीं है? हेलो, हो क्लास में? अच्छा, बाकी किसी का सॉल्व हुआ कि नहीं हुआ? श्रीहरि,
No, ma'am.
व्हाट सॉल्व
It
नहीं
is,
हुआ?
no, not solved.
व्हाट, व्हाई?
Ma'am, I don't know how to solve.
You were in the class yesterday?
No,
You attended the practical, right?
no.
Why?
मैम आंसर क्या
I
है?
don't see, ma'am.
हाँ,
मैम आंसर मेरा 104 है.
मैंने तो सॉल्व नहीं करा है. फॉर्मूला दिखा देती हूँ. दिस इज द फॉर्मूला.
मैम 102.7 आ रहा है मेरा.
तुम्हारा भी वही आ रहा है?
मैम 102.7 मैम.
ओके, तो फिर वही होगा. But formula for those who were not there yesterday, this is the formula. So P is the value, D1 square is the distance divided by 1 upon D square. Have you all written the formula? Srihari, I'm going to ask you the answer for this.
Yes, ma'am.
Shivangi,
Yes, ma'am.
have you solved it?
Ma'am, I'm trying.
What are you trying? Tell me what have you written in the equation?
Ma'am, actually, I've just seen the equation. I'm not there in the last class.
Okay. Shivrat,
Yes, ma'am.
you were there yesterday, right? Anna?
No, ma'am.
No, you were there. I think I remember. नहीं थे?
नहीं, ma'am.
ये ना अटेंडेंस गड़बड़ हो गई है. Pranisha,
Yes, ma'am.
you were there yesterday?
No, ma'am, but ma'am, I got 103.
You got 103. What did you do? How did you solve it?
मैम वही फॉर्मूला लेके ना पहले पॉइंट का वैल्यू लिया और फिर वही डिस्टेंस का
कैसे
डिस्टेंस का स्क्वायर. हाँ,
वैल्यूज कैसे लिखा? 100 divided by
1 स्क्वायर प्लस 105 डिवाइडेड बाय 1 स्क्वायर. फिर डिवाइडेड बाय 1 बाय फिर से वो डिस्टेंस का स्क्वायर लेते हैं ना.
Okay. बाकी everyone else, Prakriti, Oluremi,
I'm still thinking.
Prakriti is still doing. Oluremi, did you write the formula? Okay, so what is the formula? Hmm. Hmm. So you need to complete the formula. You don't have the whole formula. So why did you not ask? How would I know? Tell me that you have written the formula or you have not written the formula. I cannot see you. Right? So you need to be more active and ask the questions. It's okay to ask in the class. Write the formula. I'll wait for 5 more minutes for everyone to solve this question on their own.
Ma'am, how to take the D, ma'am?
D is your distance.
So in this case, we have to count the grid size.
In this, you are just taking the distance from this to the point. So if this at 1 and here it is at 3, so your distance will be 2.
Okay.
Ma'am,
Hanji,
ma'am, how to measure this 115 payload distance?
okay. Okay, Ruchi, you tell me this. Ruchi,
Yes, ma'am.
how did you take the distance from 115?
I considered only 3 points, 100, 105 and
मैम पर 100 के लिए भी वैसे करना पड़ेगा तो मैम वो 1 और
1
3 का
मिनट, बाकी जितने हैं जिनका 102 आया उन्होंने कितने पॉइंट्स कंसीडर किए हैं?
Ma'am, 3 points.
3 points.
ये सबने
Not 3 points.
कैसे 3 पॉइंट्स कैसे चुना तुम लोगों ने?
so the nearest ones.
हाँ?
Ma'am,
Why
this
the nearest
100
ones?
5 and 105 और 3 nearest points ले लिए.
Yes, ma'am.
मतलब तुम लोग बिना बात किए आपस में you could choose the 3 points. Every one of you, every single one of you.
Ma'am, I did for all the 5 ones.
Who is saying this?
Ma'am, Pretna.
Prerna. Okay, how did you choose the distance for this 100 and 115?
Ma'am, using the formula, the coordinate formula होता है ना, under root 2x
So
minus
what?
x1.
So what are you getting the answer here?
Ma'am, I got the answer 102.8.
Okay, even after using it with the coordinate, it's the same answer.
Yes, ma'am.
So you would have used the coordinates for all these three also?
Yes, ma'am.
Okay. So yes, I think you should be using the Euclidean distance here, everyone, and not just the simple distance.
यस मैम वही किया था तो
हाँ
102.7 आ रहा है
उससे भी 102.7 ही आ रहा है
यस
आंसर।
मैम मैम ऑल द 5 पॉइंट्स कंसीडर करने से भी 102.75 आ रहा है
रुचि
वर्टिकल हॉरिजॉन्टल स्केल पे वो वेरी नहीं करेगा ना, वो डायगोनल वाले पे
यस मैम
we
तो
need
मैम
to
वो
go.
तो मैम 115 के लिए तो 5 आ जाएगी वैल्यू और 105 के लिए रूट 10 आएगा या रूट 5 आएगा शायद हाँ रूट
Yes,
5
root 10. Root 10.
रूट 10 आएगा यस मैम
रूट आ रहा है, चलो करो सॉल्व
तो मैम
करो
वो
बाकी
स्क्वायर
लोग
में ही है तो एनीवे हट जाएगा
हट जाएगा ना, वो स्क्वायर में आएगा। बाकी लोगों को समझ में आया कि नहीं आया? यूक्लिडियन डिस्टेंस, व्हाट इज द फॉर्मूला फॉर द यूक्लिडियन डिस्टेंस?
Ma'am,
हाँ
under
रंजीत, नहीं प्रेरणा से नहीं पूछा, रंजीत रंजीत
No, ma'am.
ओके सुजाता
मैम अंडर रूट x1 माइनस x2 का होल स्क्वायर प्लस y1 माइनस y2 का होल स्क्वायर।
ओके सो एवरीबॉडी एल्स गॉट दिस, जिनको फॉर्मूला नहीं पता?
Yes, ma'am.
विद्यालक्ष्मी डिड यू गेट द फॉर्मूला?
Yes, ma'am.
मैं आगे नहीं बढ़ रही हूँ, यू नीड टू सॉल्व इट नाउ। हुआ बाकी लोगों का सॉल्व? और जब तक सब सॉल्व कर रहे हो, यू नीड टू टेल मी कि one test and after that you want to have one more test for your internals, or would you like an assignment?
मैम असाइनमेंट
presentation or written assignment?
रिटन।
ये देखो, और फिर कहाँ क्या करोगे रिटर्न असाइनमेंट में? कॉपी कर करके दे दोगे?
मैम अलग अलग टॉपिक दे दीजिए सबको।
कॉपी इन द सेंस गूगल से कॉपी पेस्ट करोगे पीडीएफ बनाने में?
नहीं मैम आप छोटा सा वाइवा ले सकते हैं उस टॉपिक पे भी।
ऐसा काम करो ना जो थोड़ा सा मेरे ऊपर भी लाइट पड़े और यू ऑल्सो डू इट। 4-minute presentation everyone, या 5-minute presentation in the groups? बोलो बोलो।
मैम 5 मिनट प्रेजेंटेशन इन द ग्रुप।
हाँ ग्रुप ऑफ 3।
मैम 5 मिनट ईच या 5 मिनट में तीनों को बोलना है?
5 मिनट में तीनों को बोल लो यार, कहाँ तुम लोग 5 मिनट 15 मिनट प्रेजेंटेशन तो बहुत हो जाएगा।
Yes, ma'am.
ओके मैम।
5 मिनट से थोड़ा सा बढ़ा लो, 7-8 मिनट कर लो, ग्रुप बना लो।
ओके मैम।
और टॉपिक्स जो पूरा कोर्स है, यू वांट मी टू डिवाइड और यू ऑल कैन डिवाइड अमंग योरसेल्व्स एंड ग्रुप आल्सो? डू यू
मैम
हैव
आप डिसाइड कर दीजिए।
क्या दे दूं? टॉपिक्स आई शुड गिव
यस
Yes,
मैम।
ma'am.
and groups and groups
रोल नंबर वाइज कर सकते हैं।
हाँ
रोल नंबर वाइज कर सकते हैं उसको।
वो भी मैं रोल नंबर वाइज कर दूं?
हाँ
यस
कितने स्टूडेंट्स हो टोटल?
42 अराउंड।
42 हो तुम लोग? चलो तो रोल नंबर वाइज तुम लोगों के पास लिस्ट है कि मेरे को तुम लोगों को ग्रुप में करके देना है?
मैम है लिस्ट में।
तो आप ये बता दीजिए एग्जामिनेशन रोल नंबर वाइज या फिर क्लास रोल नंबर वाइज करना
है उसमें भी अलग अलग है? हाँ अलग है।
है? यस मैम।
एग्जामिनेशन वाले के हिसाब से करो।
ओके मैम।
हाँ क्योंकि उसी के हिसाब से मेरे को मार्क्स देना होता है ना, एग्जामिनेशन रोल नंबर वाइज। ओके सो आई थिंक देयर विल बी 14 ग्रुप्स अगर 42 हो तो 14 groups will be there, right?
Yes, ma'am.
Yes, ma'am.
And when do you want to have it? End of March.
मैम एंड ऑफ मार्च में सबका एक साथ आप लोग या वीक्स में आप ले सकते हो, मतलब ग्रुप्स का वीक्स
नहीं मैं ग्रुप्स में बीच में ही लूंगी, लेकिन how much time do you need to prepare ना? We can start it at the end of March or you want to start it before? Maybe after the Holi break. I think Holi is on 18th of March. So after that, when the next week starts after 18th, बाकी लोगों ने क्वेश्चन सॉल्व कर रहे हैं ना? Where is the calendar? So 18th March. So 21st is a Monday and your class will be on 22nd and 23rd March. So on the maybe on each Wednesday I'll keep it. So 23rd Wednesday would be the first group. 23rd March.
Okay, ma'am.
And I think I'll take 3 groups or 4 groups in one time. 4 groups. Let's keep it 4 groups. So 3 classes में हो जाएगा 4 groups. Okay.
Ma'am, was it group of 3 or group of 5 students?
Group of 3. Group of 3 students. ठीक है? And I have to give you the topics or you can take it.
हम टॉपिक्स असाइन कर दीजिए।
टॉपिक्स भी मैं ही असाइन करूँ? अच्छा 14 ग्रुप्स हैं। ओके चलो मैं लिस्ट भेज दूंगी फिर 14 वो बना के। ठीक है? I'll send it by tomorrow. Okay?
ओके मैम।
ओके हुआ सॉल्व हुआ सबका कि नहीं हुआ अभी?
यस मैम। हो गया मैम।
हो गया? कौन बोल रहा है ये?
मैम
देवशीष? हाँ कृति?
यस मैम।
ओके
102.7।
ये जयदीप डिड यू सॉल्व इट?
कर रहा हूँ मैं।
अरे क्या करना है? क्या यूक्लिडियन डिस्टेंस आया बिटवीन this point and this point here? What is the Euclidean distance here? फॉर्मूला बताओ जयदीप। कहाँ गया ये? ये कहाँ गया? ये देखो गायब हो गए। एक तो तुम लोग ना ऑनलाइन क्लास में गायब हो जाते हो। फिर से आया कि नहीं आया? चलो देवशीष तुम बताओ तब तक।
यस मैम। मैडम हो गया 102.86
ना
हो गया।
पूरा नहीं बताओ मुझे यूक्लिडियन डिस्टेंस बताओ दिस पॉइंट और दिस पॉइंट के बीच में।
किसके?
इस ये यूक्लिडियन डिस्टेंस बताओ कितना होगा यहाँ पे?
ये एक मिनट।
सॉल्व किया होगा ना?
तो मैडम मैंने डायरेक्ट कर दिया था, हाइपोटेन्यूज निकाल के नहीं किया था।
डायरेक्ट किसमें?
मैडम मतलब वो डायरेक्ट डिस्टेंस वो हाइपोटेन्यूज निकाल के 100 और 115 का निकाल के मैंने कर दिया था मैडम।
तुमने डायरेक्ट डिस्टेंस निकाल के किया तो
Yes,
यू
ma'am. मैडम
हाँ बोलो।
मैंने तो डायरेक्ट कर दिया था, तो अब इसका निकालूं?
अब इसका निकालो, तुम लोगों का आंसर किसी भी उससे सेम ही आ जा रहा है।
कुछ लगभग सेम आ रहा है मैडम, 102.86 आ रहा है
मैम बस
यूक्लिडियन
पॉइंट डिफर करेगा ना, अगर डिफरेंट
हाँ
पॉइंट कंसीडर करेंगे
हाँ
तो मैम 102 तो आएगा ही, फिर 0.8 या 0.7 आ रहा है।
हाँ, उससे ज्यादा फर्क नहीं पड़ रहा ना।
यस मैम।
विद्यालक्ष्मी,
Yes, ma'am.
सॉल्व हुआ?
Yes, ma'am.
क्या, व्हाट डिड यू डू?
Uh,
व्हाट्स द यूक्लिडियन डिस्टेंस बिटवीन दिस पॉइंट एंड दिस पॉइंट?
ma'am, I consider this one. No,
What
just
is the formula of the Euclidean distance?
root over x1 minus x2 whole square plus 1 y1 minus y2 whole square.
So this is your Euclidean distance formula.
Yes, ma'am.
Okay. So what we have to do is, we have to calculate, when we are doing a semi-variogram, we have to calculate the distance for all the points. Okay, everyone?
Yes, ma'am.
So we are calculating the Euclidean distance here using the formula this between all these points which we have. So between this point with this point, whichever point you have, so you will have these many combinations here. Okay, so first you have to calculate this distance here. So you get the distance is this between particular points, right? Then we need to calculate the empirical semi-variance value. So what will be that value is, you have the value at one location minus the value at the second location, you do the whole square of that location, that value. So you get this whole square, you divide it by half, you get the semi-variance value. So this is for all the known points here, what you do. Everyone gets this? Are you all able to get these values? You can get these? बताओ भाई.
Ma'am, please repeat. क्या?
So what we are doing here is, कैसे दिखाई नहीं देगा? We have to first make this semi-variogram. So what we need for this is, we need to get the distance between the two paired points, and we need to calculate the semi-variance, that is the half the difference squared between the pairs. So we take the distance into consideration and we take the value into consideration. So if we look at this first location, we have 1, 5. So 1, 5 is this location, 3, 4 is this location. So we have these 2 points. So what is the distance between these 2 points? How do we calculate it? We calculate this, the square root of this. So we get 2.236 here. Okay,
Yes,
right?
ma'am.
So this is the distance we get between this and this point here. Now what is the values here? It is 100 and 105. So value I minus value j whole square. So the difference between these two values is 5. The square is 25 and half of 25 is 12.5. So you get the semi-variance value. So you got the distance, you got the semi-variance. So you have to do this for all the combinations here, or for all the known points. So this and this and this. Everyone gets this?
Yes, ma'am.
Okay. So this is to make your semi-variogram or plot the points on your semi-variogram. Okay. So once you have this, you need to create or get the slope of this. In this particular condition, when we are taking as a linear slope, we got the value of 13.5 here. Okay, so we have to create a gamma matrix here. What we are trying to do here is, we are trying to create an equation or create a matrix to get our value for that particular unknown point. So we get a gamma matrix here. For this gamma matrix, we make it in the Excel sheet. We put all the 5 known points and we multiply with the slope. So slope into h. What would be the h value here? The distance between that location and the slope. You get the slope from this fitted line here. So slope into the distance. So if you look at 1, your distance is 0. So that this gamma value is 0. Distance between 3, 4 and 1, 5 is 2.236. So if you multiply 2.236 with 13.5, you will get a value of 30.19. So you create this gamma matrix for all the values here. Everyone understands this point, what we are doing here? Everyone? You can try this part. You can try getting this slope in Excel. You put that points, what you have, this distance and the semi-variance. You plot this in your Excel or anywhere and you calculate the slope and see if you get the slope as 13.5 or not. So if you get that slope here, 13.5, and then you can create this matrix here. After this matrix, what was, or the slope what we get was for the, if you can see, we have fitted a linear line here. So we have this here, but you can have other methods also. So as you increase or change the trend lines, your equations become little more complicated. So for simple understanding, we have just used a linear fitted line here to keep it simple for understanding purposes. So once you have this is your gamma, okay? It contains weights assigned to the measured values surrounding the location to be predicted, okay? So we got this gamma matrix. We have to calculate this lambda values, and you have this g value again. So this g value you get with the distance between the point and your slope. So you have these points from that location and this is the distance from that location, and you get the g value here. How you get the formula was this gamma matrix into lambda is equal to g, and you take the inverse of this. How do you calculate the inverse of a matrix? Anyone knows it? किसी को पता है? किसी को पता है?
I think rows and columns को interchange कर देते हैं.
Inverse of a matrix is 1 upon determinant of A into adjoint of A. Okay, so I have not written the formula here, but did you get what I say, or should I be writing the formula?
Share the formula.
Okay, my writing will not be good, as you know. Physical class is so important. इसकी जगह तो मैंने इसमें डाल दिया था फॉर्मूला. So A inverse or gamma inverse is equal to 1 upon determinant of A into adjoint of A. This is the formula to calculate the inverse. Now this is a big matrix, so it's usually difficult to solve this big matrix by hand. So you use usually the softwares to calculate these inverse matrix. The properties you need to remember is these matrices, when you are calculating the inverse, are usually square. So you take that many number of points only in calculating these inverses. How do we calculate the determinant if we have a 3 by 3 matrix? Anyone knows it?
मैम
नहीं पता, बताऊं कि नहीं बताऊं?
मैम बता दीजिए।
इतना मैथ्स मैथ्स करना है?
जस्ट एग्जाम्पल थोड़ा सा कैसे सॉल्व करते हैं।
ओके
मैम वो
सो
मैट्रिक्स बनाएंगे मैम
बोलो।
वैसे मैम 3 by
हाँ
3 डिटरमिनेंट को मैम वो 3 मैट्रिक्स बना लेंगे A1 फिर वो मैट्रिक्स ऑफ B2 C2 B3 C3 करके वैसे ही ना, फिर माइनस C1 उसकी फिर एक मैट्रिक्स बनेगी 2/2 की और फिर प्लस C1 2/2 की मैट्रिक्स बनेगी।
किसी और को समझ में आया? किसी और को समझ में आया? ओके वेट, ओके क्या हुआ? Okay, can you see the Excel sheet?
Yes.
Yes, ma'am.
Yes, ma'am.
Okay. Okay, can you see the numbers? I'll write some numbers here and then you'll calculate the first determinant here. Okay, so if we have first a 2/2 matrix here. So if you have a my system is really slow. 4, 6, 7 and 2. So what would be the determinant value here? We multiply first this and this minus this and this. Multiply. So it would be 4 into 2 minus 6 into 7. What would be this?
-34.
Array. Huh, minus 34 is the answer. Everyone got it? Everyone understood it? So this is for a simple 2/2 matrix, right? You get this answer as minus 34. So this is known as calculating the determinant of your particular matrix. Now, if you have a 3/3 matrix, so what should you be doing in 3/3 matrix now? Who wants to repeat? Tell me. Who knows it?
4
Yes.
into
Yes, ma'am.
पता है?
जी मैम।
Yes,
ma'am.
ma'am.
तो अभी तो बोला सबने नहीं पता है, अब पता है? चलो करो, मैं एक मैट्रिक्स देती हूँ, कैसे सॉल्व करोगे? 9 इसको कैसे सॉल्व करोगे?
-8.
-8, ma'am.
-8.
Yes, ma'am.
कितना आया?
-8.
-8.
-8.
डिटर्मिनेंट -8 आया, मैंने सॉल्व नहीं करा है।
-8 ही आ रहा मैम।
-8 आ रहा है, सबका आया?
Yes,
Yes, ma'am.
तो सबको डिटर्मिनेंट सॉल्व करना आता है ना? राइट?
Yes, ma'am.
Yes, ma'am.
तो तुम इसे सॉल्व क्यों करवाया 2/2 जब
मैम
आपने
मैम आपने बोला था कि फॉर्मूला बताओ, वो फॉर्मूला बताने में डिक्टेट करने में प्रॉब्लम हुई इसलिए।
अच्छा ठीक है, तो फिर इनवर्स भी आता होगा?
Yes, ma'am.
Okay, so for a smaller matrix it's easier to calculate rather than for this big matrix. Okay, so I think you can do that part now. We got this vector G also, so you can solve this based on this lambda inverse into G. So you get this for every point. You have the
Ma'am,
G
your
value.
presentation is not visible.
My presentation is not visible. Why?
Ma'am, you are not sharing.
Sharing कब बंद किया मैंने? अभी visible है?
Yes, ma'am.
Okay, so we had got this G value, we had got this inverse value. So for all the required points, that is we have the 5 points, for the 5 points we'll have this inverse value into G, we'll get the required weight, and we have the value, we multiply this and we add this, so we get this value which is 102.62. Now you will say that this is nearly similar to what you had with the IDW also, because this is a very small problem or a little amount of data is there. But as you increase the complexity in this data and you have more and more data here, the values will have a difference in that. Okay, so this is how you get your value here. But after this, you also get the Kriging variance and your standard error also. So how do we get? Again, we have this G vector here. You have this weights. You multiply these here and you get, by addition, you get the standard error and the variance. These factors are missing in your IDW. Okay. So these are the two other things which you need to calculate in this. Okay. Somewhat everyone gets it?
Yes, ma'am.
Yes, ma'am.
Okay. So if you look at from the exam point of view, I might give you small data sets, not this big, and I might just ask a part of it. Okay. So accordingly you calculate it, right? And the last is your co-Kriging. When we are saying co-Kriging, that means we are not relating only one variable. Well, instead we are basing our estimation on maybe 2 or 3 variables here. So that is your co-Kriging. I'm not giving the mathematical part of this co-Kriging here. I'm just telling you what it is. Okay. So that's it for today's class. Any questions, anyone? Anyone? No? सबको समझ में आ रहा है कि नहीं आ रहा है?
Yes, ma'am.
Yes, okay. So we'll have next class. I think next class will be also online only. But if you are coming to the department, then let me know.
Okay, ma'am.
Okay. Okay. Logging off now. Okay, bye.
Thank you,
Thank
ma'am.
you.
Thank you.